Okay, let's look at this one. I'm intentionally looking at this problem for the first time while recording, just because I think it's more authentic, and like helping you solve a maze when I have not solved the maze yet, I think is the best, rather than like, here's a maze I've already solved. Anyway, go left and right, the end. I think this is more organic and better. So 2 blocks of the same mass but different material slide across a horizontal surface. So we have this one and this one, and they go whoo when they're sliding. Rough surface, so we have friction. They eventually come to rest because there was so much friction. This one made it further. Okay. A graph of kinetic energy versus position is shown. So this one came to a stop sooner. So this is the second one. This one went further. So this one was slightier. So force of friction is lower. This one came to a stop pretty early. So friction is higher. Maybe this one was made of sandpaper and this one was made of like ice. I don't know. Okay. Which of the following is a true statement about the force on the 2 blocks? Ooh, we need to know exactly how much. Well, we know force of friction 1 is less than force of friction 2 for sure. So let's see. That means if we had half, okay, 5 is less than 10. Half of 5 does not equal 10. That's dumb. Half of 5 does not equal 10. Twice 5 equals 10. Maybe. I know it's the right answer, but we're going to pretend we don't know. Twice 5 equals... So we know it's either this one or this one. Just look at the math. So then we look at the example and say, since the force of friction is represented as the slope... Oh, is it the slope? Or the inverse of the area? Ooh, fun. Okay. So, work is force times displacement, and it's also, let me move my face, change in kinetic energy. So they both go from final of like 0 to initial of more than 0. So work is just negative final, and that also equals force times distance, which is the area. Ooh. Force times distance, a really long area. Inverse of the area. Yeah, negative. I really like this answer since friction is the inverse of the area bound. But it says it's the slope. The slope. Slope, so slope is change in y over change in x, which means change in kinetic energy over position, call that distance. What? Kinetic energy equals force times distance. Kinetic energy over distance, that equals the force. Oh, force times distance is the area. But we're just looking at the force. Okay, this is wrong. This is right. Change in kinetic energy over the distance, that gets you your force. So change in y over change in x. This is our y, this is our x. The force of friction is the slope. Why did they say inverse of the slope? Oh, they don't. It is the slope. Okay, good. If it was like d over k, if they were swapped, that would be inverse of the slope, but it is the slope. Wow, that one was really hard. Okay, there's that one.